Right, welcome back. So hopefully everybody had a good reading week. So I think we got another 13 lectures to come, right? We got total 24. We already finished 11. So we got 13 more to come. So I'm planning to finish talking about the equality maybe in the first 3 lectures of the, this week, and also maybe Tuesday next week as well. And then we're gonna dive deep into inheritance. You definitely got lab number 4 as well to really practice about inheritance and also your upcoming programming test. So after inheritance, we got about 3 lectures-ish left, in which case I want to cover one more topic for the course, which is recursion. And that one will be a very good transition for you to go into 2101, which will be the sequel to this course, data structure. So that's why I want to cover usually recursion the last, so you can make a smoother transition. Okay, so that's kind of roughly the plan. If we have to, we can go faster, we go faster. If we got to slow down, we slow down. You can let me know. All right, so let me make some quick announcement just to clarify where we are. And then we'll do some very quick recap. All right, let's see. Grading is ongoing. The TAs are supposed to get back to me about their preliminary result today, this afternoon. I'll check out with them for sure. And then once I get the result back, hopefully in time today, it will take me just 1 day or 2 more just to finalize the result. So optimistically, you can expect to hear back from me about Friday, about the test result. I'll return back to you both tests at one go. And you can definitely look at the feedback, and then if you want to submit any regrading request, or if you want to speak to me, office hour, no problem, anytime, okay? I'll keep you posted. And your written test number 1 will be next Wednesday during the lab time, the same usual time. However, this time, I think, please double check the guide, right? I don't want to say anything that's wrong. It's the Wednesday next week, not tomorrow, right? You might get a heart attack, right? If I say it's tomorrow, right? So it's next week, okay? So tomorrow, so today, I'm going to, either today or early tomorrow, I'm also gonna release your lab number 3. So for you to do. So that one there will be a relatively simpler lab, just some very simple practices about implementing equals method and maybe some reference aliasing. It's gonna be a very pleasant lab just to practice. And lab number 4 will be the more challenging one, but so it's for later. All right, so you already got a practice question on the E-class. So what I plan to do is this. So guys, again, I apologize for choosing such an unpleasant time on the weekend. That's the only time I can kind of spare to really give you a proper review session. So I think I will do that either maybe later today. I'll really put on my to-do list. So there, the practice question there, I already put on the E-class. There was one review session that's recorded by one of the TA, very quality session. I'm gonna put that recording on the lecture site today. So if you just want to go over the solution with some explanation, some nice presentation, you can definitely follow through the recording. So if you can really make it to Saturday 4 p.m. for the Zoom session conducted by myself, you can maybe ask other questions. Maybe you want me to repeat certain topics in the lecture, or maybe something else. So you don't really have to focus on the practice question, because in some way, they are not going to exactly represent what's going to happen in the actual test. Might be to your best interest to ask me something else. All right, anyway, I'll leave this decision to you. I'll definitely reach out to you about some walkthrough of the practice question. I do have the recording. I just need to send you the link, right? And lab 3. Okay, I'll release that to you pretty soon. Guys, question, please. All right, good. Okay, let's now do a very quick recap, and then we'll move on to continuing with the object equality, okay? So before the reading week, we basically spoke about the last set of examples for designing the JUnit test. Specifically for this exercise here, you want to pay attention to, for this test, you actually got phase number 1 and phase number 2. In phase number 1, you do not expect to see this kind of exception, in which case you're going to fail if that happens. On the other hand, in phase number 2, you do expect to see that exception. So that means if you're able to go to the next line without having that exception, you are going to fail, right? So just remember about where you're going to put a fail assertion when you actually study for this particular part. That's very important. And I think one of your practice questions on the E-class actually addresses this to see how you can actually use a nest to try and catch. Oh, let me just say that more in connection with this. So one of the exercises we did also before the reading week is about if you simply use a console tester like a printing out error to the console. That one there is not going to disrupt the flow right away when error occurs. So that's inappropriate. So in the practice test, I kind of showed to you there is a way to really somehow structure the try and catch in a way that's going to make the console tester work by using nested try and catch. I believe you guys kind of asked me a question maybe before the reading week. I kind of hinted that it's going to be on the practice question. So please take a look, the practice test. Okay, it's going to be connected. And then we also talk about if you only got a single try and catch, even though it's a JUnit test, you know that from phase number 1 and phase number 2, you simply got the opposite expectation. So if you really got some exception thrown, you don't really know whether you should pass or fail the test. So that's also not appropriate. So you got to make sure you know about how to have multiple try and catch whenever necessary. Okay? And then the final example we talk about is to patternize the assertions. So rather than writing a large number of assertions, because if you got a very, very wide range between minimum and maximum, you don't really have to write out, let's say, 1,000 assertions. You definitely don't have to. You can just simply put them in a loop. All you got to adjust will be the minimum and also the maximum for the loop counter, and then everything else will actually work. Doesn't matter how you set the value, right? So I would say take a look at this example here and try to see if you can create something similar, maybe for your lab number 2 or maybe the previous lab, to see how you can recreate it. The best way to understand this even better is to try that yourself. Okay. All right. And so that's about the JUnit exception lecture, which is definitely going to be covered on next Wednesday, written test 1. So this week, I will just cover a little bit about call by value and also some limited extent to the object equality. I'll do a little bit, but whatever we cover this week, which will be today and also Thursday, they will also be covered in the written test 1. I will confirm about the exact slide you have to study up to, but you can already start about your preparation. Okay, I'll confirm after Thursday class. All right, so let's now do a very careful recap or like a revisit of this principle here, because we're going to need it right away for today. So we talk about a principle called call by value. Okay, so if you recall, when we first introduced the idea about when we first introduced the idea about caller and callee, we said that every time if you have a single line of method call, again, you got right away you got caller and callee. Call by value follow the same kind of context. Whenever you have a method call with certain argument value, in that way you got a call by value principle right away. So the way it actually works conceptually is like this. This is the actual method call. This is the definition of the method being called, right? You got to look at these two. And when you execute or step into the execution for this particular callee method here, you're going to execute line by line. We know that pretty well. However, call by value tell you that the parameter is actually going to be initialized using the argument value, which will be this particular variable assignment. We say parameter, which is right here, is going to be initialized to the value of the arguments, right here, like a variable assignment. And this is going to be done first before everything else will actually happen. So in the Eclipse, whenever you say step into the execution for M, this initialization call by value has already been done. You have no choice. You have no control over. So you got to know what this is going to do. Okay? So one complication would be when you look at the variable assignment here. We also did in the OOP review, when both of these are primitive type, you're just copying simple value like integer, Boolean, character, etc. However, if both of them are reference type, so you're still copying value but copying address. In that way, you're creating some aliasing. That's something we'll have to revisit as well. All right. So when you revisit this particular example here, make sure you understand about the connection between the caller and also the callee. And also the call by value is really a way to initialize the parameter so that you can execute line by line in the body of the method in the callee. All right. So there are at least two places we have to use the call by value in this course. Okay. One will be when we talk about the equals method, which we'll see most likely maybe on Thursday. Okay. So another more advanced use is when we talk about inheritance. Whenever you actually want to call some arguments, but with some inheritance relationship behind the scene, how would you deal with it? That's something we'll see later. And the example we did before the reading week was the circled example. you can see either you got some integer over here, or you have some reference type right here, right? So I will encourage you to revisit those two examples just to be sure you understand. But today, we're going to do one more set of examples just to brush up your mind. It could be tricky when you first learn it. Let's do one more set of examples just to clarify. Okay? So guys, any questions about the principle over here conceptually? Let's clarify that. Make sure you're okay, and then I'll do the example. Anyone? All right, good. Let's now do it. All right, so the example I'm going to do here is here. So if you look at the slides, right here, so that's a call by value principle on slide number 3. And then, so for starting from slide number 4, we're assuming that we have a class called point with x and y. Okay, that's the class we're going to play with, especially when the parameter and arguments are reference type, like a point type. And we got x and y, and also we got some mutator here. Let's say move vertically, in which case we modify the y value. And also move horizontally, in which case we modify the x value, right? Pretty straightforward, okay? So in the next few slides, it's just about some different scenario to consider. Right? Let's just switch, okay? We'll talk about it. So let's see the two classes we're going to deal with. Again, the caller and the callee. So the caller in this case is just a JUnit test method right here, okay? And then we're going to create some callee objects utility, okay? And then we're going to call some method. In the actual callee class, we got 1, 2, and 3 methods, but we're going to call them individually one by one. Okay, for now, please only focus on just this one here, where we got some integer parameter. And then we're saying that when you call the method, for example, you might pass the value, let's say I over here. I is simply 10. When I pass the I here, its I value is going to be modified. Because here I say parameter, whatever it is. So if you think about conceptually, we are really replacing this j by I. So am I actually going to modify I by 1 right here? That's the question. All right, it's a very common question to ask you. Okay, you might already know the answer, but let's trace it. Okay. Okay. Let's now take a look. Again, let's now trace it by labeling the execution sequence. Okay. So first one. Okay, create a utility object. We don't need to draw it. It's not important for this particular tracing. And then we got a primitive value, I. Okay, I'm going to put I right here, which is 10. Okay, and then the next assertion should be trivial. I should be 10, pass. And then I'm going to call this method here. So let me say number 4 over here. I'm calling this method here. And this method call corresponds to this particular definition of the method, right? And we know right away that there is going to be some call by value happening, okay? So here I can simply say call by value. And the call by value is going to be the j parameter is assigned the I arguments. So it's going to be j assign I. So this is something that once you get more proficient about tracing call by value, you don't really have to write it down explicitly. But for now, I think it's good to write it down just to remind yourself. Right? Parameter j is initialized to the value of argument I. All right? So think about calling this is like a number 4. This particular initialization call by value is number 5. Okay? You can think of it that way. So I'm going to put number 5 right here. All right, and then let's now step into, before that, what's going to be the effects? So basically, we got our parameter j copy right here. It's a different copy already. So when you are calling this method here, you're using the I value. Is the I value ever going to be modified? That's really the question. All right, but visually speaking, you can see that when we actually execute this particular method, we are only going to manipulate in terms of this j here. We are never going to be able to touch this. There's no way. It's just a copy. If you're programming, for example, in C, there might be a way for you to get the address of the integer variable. But luckily, that's not the case for Java. You're simply, you don't have that ability to do that. So you don't need to worry. All right. All right, let's now move on to trace So now we got number 5, and finally we got number 6. Number 6 here is going to modify just this particular copy. All right? Increment it. So when we are modifying this copy here, we are not really changing I. I always stay the same. All right? That's a critical thing to notice. All right? So after 6, we're going to go for number 7, just to assert. You can see I value here stay to be 10. Okay? You can say that this argument value is not modified by the method call. Stay the same. Meanwhile, this particular is the copy. The copy of the arguments I is modified. It's very important, even though it's only about primitive type, it's very important for you to see why the blue I over there is not modified at all. Only the pink J, purple J there. Any question about this one here? All right, so let's now try to, so the primitive type is really not much to say, just about copying some simple value. Let's now talk about reference type, okay? So we're going to look at just the same two classes, but we are going to call a different method, okay? So now we're going to call this method here instead. And the parameter here is a reference type, it's a point class. And we assume about the point class, right? I just put it here for your reference, okay? That one we know pretty well. So now we want to think about, in this method body here, we are basically trying to modify the value of Q here to be some new reference, which is a local variable, NP. That's what we are trying to do. In some way, it's a little bit like when we say J here is modified by some value. So here we are saying that Q here is modified by some value. We're doing something very similar. Rather than reassigning some integer, we are reassigning some address. Now the question is, if I make a method call right here, using some reference called P, is P itself, the address value, going to be modified here into NP? That's a critical question. Question or answer? Answer?
In this case,
you think that will be modified?
Q in this case will be modified, and this will be changed. So, because as we're doing reassign that, a new address will be made when you do new point, and then this new address will be set to Q. So when you access Q later,
let's take a look. Yeah, I definitely agree. Q will be modified for sure. But the critical question is P going to be modified?
P itself?
P itself.
P itself, no.
Okay, we'll see.
If you change Q in this part, or reassigning, then no problem.
Let's see.
Now it will not be changed.
Sure. I agree with you, but let's take a look. Okay. So guys, let's now trace this one together, right? I would say this is like a part 1 for reference type parameter. All right. So let's now trace it. Okay, let's be careful, be systematic. Number 1, we create a utility objects. Number 2, we are creating some new point objects. And we got P here, stores the reference of a point objects. And by the way, so this will be kind of the trace that you might need for next Wednesday. Right? So for next Wednesday, you can definitely expect a lot of tracing needed for aliasing, maybe for some method call. And you want to definitely review like a lab 0, part 1 and part 2. Right? That one can be very useful. Okay? Which I also mentioned in the guide. All right, so we got point here. And 3 and 4, we don't need to step into. Pretty straightforward. So we got X and Y. And then we got 3 and 4. Okay, straightforward. And then we got another reference here. I call number 3 here. I just want to use this reference here just to like record about where P is. Okay, so I call that ref of P before. That one there is simply pointing to just the same objects. Okay, and then I'm calling this method here. Right here. This one is where I'm making the call. And this is the definition of the method. And again, oh, I'm so sorry. Right here. And then let's now talk about callback value. which is going to be about this part here, okay? So this part here, again, let's write it down. Call by value. Q, the parameter, is initialized to be the argument P. So Q is assigned P, okay? I'll highlight it. Okay, Q is assigned P, all right? So if you think about the method call here, it's number 4. When you step into the method call, number 5 is going to be the initialization of that. So number 5 is going to be Q is just going to point to wherever P is pointing to. We're creating alias, okay? And let's also make a good notes for you. So P here is the arguments, and Q here is a parameter. Because of call by value, the parameter is initialized to be the value of P, the arguments. That's what we're doing, right? Call by value. So after number 5, number 6, and 7 will be just to execute the body of the method. So let's see number 6 right here. So number 6, sorry. Okay, number 6, we're creating a new point, MP. So MP stores the address of another point objects right here. And then we got a point right here. So we got 6 and 8. Okay, X and Y, 6 and 8. X, Y, 6, 8. So far, so good. And then here's a critical line. Also, I'm going to highlight it. This line here, right here. So let's call this number 7. This one here is basically saying Q is going to be reassigned. So now a question. If I change Q, the parameter, am I going to change the argument P at the same time? The answer is no, right? If you look at the diagram, I'm only changing where Q is pointing to. At the same time, P is going to stay. That's a critical insight, right? So after this, we're going to say Q, rather than pointing to here, is going to point to wherever MP is pointing to. It's going to point to wherever MP is pointing to. So basically, after this method call, you can see that the argument P stayed the same. It's not modified. However, the Q here, initially, it is pointing to where P is pointing to. But after the method call, it's actually going to point to right here. From the caller's point of view, they only know about P. They know nothing about Q. It's actually another scope. All right, so that's really important. All right, so after this, let's now check some assertion. So we got number 8, number 9, and also number 10. All right, 8, 9, 10. Let's check it. Number 8, P and reference before. P and reference before. They point to the same object, pass. And then we got P dot get X, P dot get X, 3, remain to be 3. P dot get Y, remain to be 4. This object here is not modified. Even if you try to reassign the parameter over here, P itself is not modified at all, because the Q here is already a copy of the address. So when you reassign that, it's just going to reassign itself. Right? It's a very important insight. Okay? The follow-up question would be, what if I really want to modify that blue object pointing to by P? Is it possible? What we just tried was I tried to say, rather than I want to modify somehow the value here, what I tried to do is I want to reassign this P into MP, but it was not allowed. It's not even possible, right? Because it's called by value. It's just a copy of the address. But is it possible by other ways? You somehow will have to make some aliasing effects. Maybe that's what you're hinting at. Well, we'll see that. That'll be the next part. All right. So guys, let me make one more note for you, okay? And then we'll move on if you got no questions. So first of all, you want to know that here. So the Q here, okay? Let me say this is star. And this is star star, okay? So the star, the arguments, which is Q, the parameter, I beg your pardon. The argument P Okay, let me do it again. So talk about the parameter. The parameter, which is Q, is reassigned to MP. On the other hand, if you look at here, the arguments, which is P, stay the same. Okay? It is very important to see that. Arguments stay the same. It's not possible to modify the address that is stored in the arguments. Simply not possible. Okay? All right, let's now move on to the next one. The next one is the only way that, because of call by value, we know that P and Q are pointing to the same objects. If I really want to modify this object itself, the best I can do is use this reference here and invoke some mutator method to modify the attribute value. That's the best you can do. Let's take a look. Okay. All right, the final bit for this example here. So we still have our callee, beg your pardon, we still have our caller right here, and also callee. Okay. So now this third method here, still we got reference type parameter. However, here we are not really trying to reassign Q like before, right? Remember before we tried to reassign here, we try to reassign, beg your pardon. So here before we try to reassign the Q into something else, right? But now we're not doing it. We're saying using the Q, we're going to call some mutator method. That one you can actually effectively change something about the arguments. But let's see. Again, let's now visualize what's happening here. So we're going to do here, number one, create a utility. Number two, we're going to have a P storing the address of some point objects right here with X and Y. So this part here is the same as before. And we got 3 and 4. And we still have this reference over here. Number 3. It is the point, ref before. It's the ref of P before. That one there is pointing to the same objects. All good. And then we have this method call right here. Okay? Oh. This method call right here. And it's referring to the definition right here. As soon as you see that, you know the parameter, you know the argument, let's now execute call by value. So you think about this is number 4. Okay? So the way they're going to be related is by call by value right here. Okay? So it's going to be call by value. The parameter Q is initialized to the value of the argument P. Okay? So that would be number 5. Okay? So we have done this a few times. Hopefully that's making more and more sense to you. Okay? So number 5 here. And then how would that change the diagram? Q is now going to point to wherever P is pointing to. Right? That's number 5. So this part here is really the call by value. Okay, so now let's now step into the method call already. So let's now try the 2 lines. And we got number 6 and number 7. Okay, these 2. So these 2 lines, we are not really modifying what's really stored in Q. Instead, we're saying that follow the address that's stored in Q because of dot notation and call these 2 methods. The first method there, move horizontally, is going to modify the X value. The second method there, move vertically, is going to modify the Y value. Right? So what we'll do is, let's see. What we'll do is, for the first one here, so follow the Q and move horizontally. So 3 will become 6. All right? And then number 7, move vertically. Again, we follow Q and then increment it by 4, 6 and 8. There's no local objects like before. You can see before we actually got some local new points. We don't have that. What we do is we directly modify the objects being pointed to by the argument P. After this, let's try. So what we have is, let's say number 8, number 9, and number 10. Here is critical, right? So first of all, let's compare P and reference before. P, again, never get reassigned. It's simply not possible to reassign P, okay? And then P dot get X is now 6. P dot get Y is now 8. As opposed to, in the previous example, it's 3 and 4. Compare with 6 and 8, right? So just remember this principle here. Again, like an application for call by value. If you actually got the primitive type or reference type, do not try to directly reassign the value for the parameter because it's only modifying the copy itself. It's not going to change the original arguments. The only thing you want to do in practice is really to call a mutator method on the arguments. In that case, you can modify the objects directly. Okay? You might see some useful application maybe in one of your labs later. Okay? Just remember that principle. Okay? Question?
Is there no way Java to pass a pointer to the memory address of the pointer to?
No. Okay, luckily no, because in that way, of course, you got to deal with the complication like how you're going to deal with a C programming language. Yeah. So in Java, it's more like a language choice. When they first designed the language, they want to focus more on the object orientation design aspect. So they didn't want to get to the lower stuff. It's also very useful, but just not the right language to use. So you don't really have any concept like a pointer or pointer arithmetic.
Change the address of PVB, you can do another type and encapsulate it if you want it. It's more complicated.
Yeah, but
complication, but
yeah.
if you really need it to, you can do
Yeah,
it.
but I would say if you really had to do that kind of workaround or hacking, maybe Java is not a language for you. You maybe would have been maybe better off using a language like C, right? Yeah. Good. All right, guys. Any questions, please, about this one here? Okay. Okay. Just before, let me see this. I think some example just came to my mind. I think I can mention that briefly to you. Okay, let's see some interesting use cases. Let's say for this. I'm trying to come up with something on the fly, so bear with me. Okay, let's say we have a class called students. Okay, let's say for student, you got the various attributes. Let me omit that information. Okay. Let's say you have one method there, which is to register a course to the students. Register. And then over here, let's say course. Well, I can put a string, just make it even simpler, right? So you can see the point. Let's say a string, the course name. You may register in 2001, 2031, 2030, etc., right? Okay, the implementation here, okay? And then let's say, okay, that's good. Let's have one more class, okay? So this actually, Java code itself should not be too surprising to you. That's something we basically have been doing in the labs. So let's say we have a class over here. Let's call that registration system. And then over here, let's say we got, of course, you can have an array of students. Let's say SS for students. And also you got an integer counter number of students, right? You know the pattern, okay? And let's say we have a method here. Void. Let's say register all. String, the course. Okay, and then I'm going to leave this part here open just for now. We're going to see exactly how to write it. Okay, so this will be the second class. Okay, so how do we use this? Let me just got one more fragment of code. Okay, that will link them pretty well. Okay, let's say we first of all create a registration system. So registration system. Let's say sys. will be, let's say, empty one, right? You can use a constructor. And then I can say, for the system, I can say add students. You can definitely put in that method there. I can say maybe student 1, and also etc. You can add as many students as you like. And add students. And here comes the critical line. Let's say I want to register a common course for all the students. Let's say all the students in engineering, they should take 1011, for example. I'm pretty sure that you took it, right, as an engineering major. So here I can say system dot register all. Let's say EECS2030G, the MATLAB course. Well, of course, if you're in CS major, that may not apply to you, right? Maybe for most of you, okay? So that's basically what I'm trying to say, right? So this might be something you have already done, but let's now draw some connection to call by value, especially for the last case we spoke about. I think you can see some connection there, just to reinforce the understanding. So guys, any idea about what to write? Over here. Over here. Yeah, you definitely got to go through the students. Yeah, for sure. Yeah. For sure. Thank you. Let's say this. For integer I0, I less than number of students, I plus plus, right? You know this pattern pretty well. I'm not going to trouble you. So here I can say something like, I want to somehow register the students. So let's say this. So I think I'm lacking some gap over here. So guys, how about this? Let me save this example here. I think I definitely need to redesign this a little bit. I'm thinking on the fly. I promise I'll get back to this one to begin with and give you a proper one. Otherwise, I might just fix on the fly and waste your time. Okay? Let me revisit. Revisit on Thursday. It's pretty much done. I just need to work out some detail. I realize it's not exactly as straightforward as you might think. Let me do that maybe on Thursday. Yeah, question? I think maybe it should have been the other way. Should have I know. Let me change that. I don't want to waste your time changing on the fly. Okay. So guys, I'll come back to this example just to reinforce the idea. Okay. I want to take a break for both all of us. Before that, is there any question about the call by value principle? Let's say here, all the three scenarios and also the principle itself. Any question? All good? All right. And I'll come back to this particular add-on example on Thursday. Okay. Why don't we take a very short break, and then after the break, I'll do some Eclipse demo to introduce about equals method, and then we'll do a little bit of stuff. All right. All right, so let's now start talking about equality, but we're going to revisit the call by value very soon. Maybe not today, but maybe Thursday. Okay. But let's now take a look at this. So on the slides, so these are the examples for call by value we just went over. So it's going to be slide number 11. So this one here just summarizes about what we know about equality. Let me just talk about it very briefly, just quickly, just to bring up to speed. And then we'll talk about something important. Okay. All right, equality. Okay. So equality. And whenever you talk about comparing values for equality, you have to distinguish between the case for primitive type and the case for reference type. And when we talk about equality, it's either we talk about the relational operator equals, or it's going to be a method called equals method. It has to be spelled verbatim, equals. Right? We got to talk about it systematically a little bit later. But let's now talk about some big picture. When you talk about primitive type, like an integer, for example. So you got integer I, 23. You got integer j, 46. And to compare the value, the only way you can write it would be I equals j. And that one is going to give you true or false. And of course, in this case, it's going to be false. Okay. True or false. It's a Boolean operator. However, you cannot write something like this. Let's say if I try this, I dot equals j. It's not even going to compile. Because to the left of the dot, we know that it should be an object for context object. I is a simple value. It's integer. It's not even an object. So this one here is actually going to give you a compilation error. It's not going to even run. Compilation error. So I here cannot be, is invalid context objects. Invalid context objects. All right. So that means for primitive type, you basically can do equals to compare the value. However, you cannot do the equals. Okay. Compilation error. All right. For primitive. And what about reference type? For reference type, let's say again, let's now use the point class. Okay, so we got point p1 equals new some point. Okay, you can pass some value here. And let's say we got another point p2 and new point. Okay, you can pass whatever value you like. Okay, question already? Go ahead.
Doesn't have equals. Is integer the larger one? Does it have equals or not?
Right. So that's an aside, but it's a good question. So what your fellow student is talking about is another class called integer. It's more called a wrapper class. Think about it as like a Java library class. I can put it here. However, let's say integer. Let's say I1. New integer 23, and also you can do integer I2 will be new integer, let's say 23 over here. All right, it's basically reference type. As you can see, it's actually capitalized I, right? So it's a reference type. So now the question is, when you say I1 equals I2, even though these two are 23. But equals here is really comparing addresses for these two because they're reference type. All right? So this one here is going to give back to you false. Because different references. And because they're reference type, you can call equals method if you wish. In this case, you're going to call I1 dot equals I2. So this is going to compile because you're calling equals on the reference type. And this one here is going to give you back either true or false because it's a Boolean method. And this one here, don't worry, for now, just understand for this one here, it's just going to compare the contents of the two reference objects. It's like I1 and I2. So it's going to be true. It will be as if I1 here is pointing to some integer objects. I2 is also pointing to some integer objects. And both of them have some value attributes. And both of them got 23 and 23. So you can see there are two different objects, but their contents are the same. So that's why when you compare addresses, it's going to be false because different objects. But if you call the equals method to compare the contents, it's going to be compare 23 and 23. Okay? But we're going to see later, because this is like an equals method from the library class, we have to see how we can customize the definition for equals method. That's something we'll see. Not today, but at least you get some example right away. Okay. Okay, for this one here, it's going to be very similar. So here, either you can say P1 equals P2. Okay. We know that it's going to be false. There are different addresses. Addresses with different references. And if you say P1 dot equals P2, just remember for any reference type, you always have the equals method available to you. But we're going to explain a little bit about why. I have to show you something like evidence from Eclipse as well. Okay, so this one here is going to compile. However, whether this equals is going to return true or false, it depends on whether or not, it depends on how you define the equals method in the point class. That's all you need to know for now. Okay, we're going to say a little bit more. The result depends on how the point class, okay, I'm talking about the point class over here, how the point class, I'm sorry to write this way, but just a little bit easier this way. The point class defines the equals. Okay, I'm just reading that to you. It will compile, and the result for this equals method depends on how the point class defines the equals method. Question?
So when we are usually using the equals method, is it comparing the value of the attributes, or is it?
It's a very good question. So equals method here, in general, you simply don't know because you can completely customize the equals method in your own class. But let's say for the string class, it's kind of beyond your control. It's already implemented. But for the string class, if you compare two string objects using equals, it's always going to compare their contents, not their references.
So is it going character by character?
It's going character by character. Yes, that's correct. But we'll get there a little bit more. Yeah, question?
So the toString method is always defined in every class, even the ones we make.
Aha.
Is the equals method always defined?
Always, exactly. So it's a very good point. So the toString method you're talking about and also the equals method, they both exist in a class called objects. Okay, well, we should get there. Yeah, the next page. Okay, good. It's all relevant. Okay. All right, so let me just summarize this and then we'll do a little bit of demo on the Eclipse. So this will be a very important demo to see. Okay, give me one moment. So for any reference type, you definitely can do equals equals, which is going to compare the address or the reference. Number two, the equals method, always you can call the equals method. However, let me say for now, okay, just take a note. That's something you will have to completely grasp maybe by the end of this lecture series. Either it's going to be the default version, or customized version. Which version should really be applied? We have to see case by case. Okay, we'll see. Okay. Let's now see some paper example and I'll demo that to you on the Eclipse as well. Okay, let's look at this example here. But based on what we just kind of summarize and talk about, these two questions should be kind of straightforward. I kind of mentioned the answer to you. So let's go directly. Okay, but let's see what the context is. Let's say we have a class called point v1. So v1 here is called version 1. We're going to have another class called point v2 as a running example. So in point v1, so this is the entire definition. So we got two attributes, x and y. Also, we got a constructor, nothing else. So the only method we have is the constructor, like a special method, nothing else. Okay. And let's say we got our point tester class, like a console application. And then we got point v1, we got two references, p1 and p2. Okay? And then it seems like we are calling equals, which is a method that does not seem to exist in this class over here. Agree? Equals method is not even explicitly defined in the point v1 class. But can we say P1 dot equals P2? Would it compile? According to the principle we set, for any reference type, of course you can use equals. Okay, so yes, it will compile, right? So let me emphasize the point very clearly here. You can think about the equals method here, not explicitly defined. In point V1. But it will compile. Okay, it will compile, first of all. Okay, and then, now, if that compiles, there's got to be somewhere we can find a definition for that equals method. Where does it come from? All right, it's a class called objects. Maybe that's something you want to say, right? Okay, good. We're going to see that exactly, right? Where does it come from? It comes from a class called objects. So the name of the class is called objects. It's a class that's defined by Java library. It's a very important class for you to know. Okay, we're gonna need that class to understand exactly what's going on. But before that, let me just show to you on Eclipse. All right, so we got our point V1 class over here. Right, you can see there's no explicit definition for the equals method. Not really. All right. And then we have our point tester right here, right? So you can see that there's no red cross. The equals method simply work, compiles. But now we want to step into the method to see which class it will lead us to, okay? So put a breakpoint here, and then line number 7, and then we're going to launch the debugger. Okay, take some time. So we'll switch to the debug perspective. And then we're going to take a look. So the execution is going to pause at line number 7. So what we'll do is now we're going to step into the execution so we can see which version of the equals method is being called. There's no version in the point V1 class. So where should it go? So if I say step into, it goes to a class called objects. And this is the whole definition for the equals method. Let's take a look. It's nothing difficult here. So whatever you're passing as the argument here, we call that obj. And then we're saying that we're just returning this equals obj. So essentially, this is the default version that's only going to compare references of the two. All right? So what I can write here is, okay, let's take a look at this. So number 2, the default version. From objects is call. But let's be more precise about this one here. Okay, put a star. The default version, if you recall, that one there says like this. Let me see if I can do this one here. I haven't done this for a while, but let's see. I might just be able to. Let me see. There we go. Okay, that's a definition, right, from the Eclipse. Oh, there we go. Okay, that's a definition. And when we actually call the object version, so from the objects, right, so that's the version we just look at. How would that turn out to be? So what's the this? Since we're calling P1, that's a context object. So this is the this. So this will be just P1. And P2 over here is the arguments. You can think about the obj here is really P2. I know call by value, but let me just make it a little bit more efficient for tracing. So obj here is really P2, right? I'm just doing the normal tracing we're doing, replacing the this by the context objects, and replacing the parameter just by argument, right? That's how we trace in the previous classes. So that means this default version will just boil down into, so this will simply boil down into comparing P1 equals P2. So what this tells us is this. for any reference type, like a class, where you don't have any explicit definition for the equals method, it's simply just going to invoke the default version from the object class, which will just compare references, okay? As if you use the equals equals. It's a very, very important detail to really know, all right? When there's no explicit definition in the class, you just use the object version, okay? And then let's now make a little bit more detail here. Okay, let's talk about this kind of conceptual model. Okay, we're going to use these two classes as a running example for the other two lectures as well. Let's take a look at this. We have a class called point v1. No explicit definition. Okay, so for this particular class over here, so think about, so for this class, point v1. No explicit definition of the equals method. Okay, that's the first class that we just went over. The second class is point v2. And this class over here, obviously you can see it's kind of bigger, it's longer, okay? Especially you can see this part right here. This part here, right here. And you can see that one is calling the equals method, which correspond to the header of the default version. All right? It is something called overriding in Java. It's a special term you have to know. All right? I'll write it down. So this is an overridden version. Overridden version. And you can think about the term overridden simply means redefined. I don't really want to use default version from the object class. I just want to use some redefined version. That's basically what you will have to do in your future lab in the programming test. All right? Let's dive a little bit deeper. Okay? So for point v2, we have this explicit definition here. Okay, let me write it down. So that one there, we do have the explicit definition of the equals method. So when you compare the differences between these two classes, they have nothing to do with each other. Okay, they're separate classes. This one here has no explicit definition for equals, and this one has it. Okay, so now let's talk about how the object class come into play. All right. So if you look at the slides, it's on slide number 12, I believe. Okay. So this is something we have to mention kind of more like an intuitive sense just for now. Because when we talk about parent class, child class, or superclass and subclass, they are to do with the inheritance, which we're going to talk about thoroughly, maybe in about 1 week or 2 weeks' time. But for now, let me just give you some intuition about this kind of inheritance, right? That's all you need to know just for now. Okay, so object class is the parent class of every class. You have no choice. As soon as you create a new class in Java, object class is already your parents. You cannot choose it, okay? So I'll write it down. So think about this is the parents or superclass. You can use the term interchangeably. You can either say parent class or superclass. On the other hand, for either point v1 or point v2, they are called the child class or subclass. Okay, let's talk about how we can understand about this kind of inheritance relation intuitively. Okay, so you can think about this is the parents, which has child number 1 and child number 2. So these two classes over here, they share the same parents called objects. All right. So now what does that inheritance relation really imply? It implies every method that's declared or defined in the parent class, they will be inherited or accumulated or be available in the child class. All right. So that means all methods inherited to. Okay, so here for our discussion, we just talk about the equals method. So the equals method will be inherited to here and also inherited to here, both of them. In this case, point V1 does not choose to redefine or overwrite the inherited equals method. So whenever you try to invoke point V1 objects on the equals method, it's simply going to call the inherited version, default version. On the other hand, this point V2 class in the first place is going to inherit the equals method as default. However, it chooses to override it. As soon as the class chooses to override it, the default version is no longer applicable. So whenever at the runtime, as we'll see later on Thursday, when you try to call point v1.equals versus point v2.equals, it's going to call different version of the equals. That's something we'll see. Okay. Ready now? So for point v1, the default version of equals from objects is used. So here the key term is about the default version. The default version of equals from the object class is used. On the other hand, if you talk about the point v2 class, it's kind of the opposite. So now here, the default version of equals no longer applicable. Okay, sorry about the writing, but I'll read it to you. So the default version of the equals, that's from the object class, no longer applicable. It's not there anymore. Question?
Are you required to put the annotation at the right when you want to override the method?
You mean the parameter here?
No, it's like the thing where you do like point V2 above the public boolean, those things you do at override for the compiler to know.
Oh, I see what you mean. Yes, I see what you mean. So in Eclipse, when you say if you automatically want to generate an equals method to begin with, it's going to say something like at overwrite. So I would say that one day is not strictly necessary. That override tag is only for the Eclipse to recognize is the overridden version. However, if you simply type it out yourself, just type it out exactly this header here, it's going to recognize it anyway. Okay, good. So in the programming test, you can either choose to somehow generate automatically, that's okay, but we can type it out either way. Okay, good. Okay, that's for number 2. And number 3, I'm going to write it out here. And number 3. The overridden version or redefined version is used. Okay, that's also a very important point. So this diagram here is your very first diagram to do with multiple classes somehow related to by inheritance. But it's a very restricted one. Okay? We're saying that every time you're creating a new class in your project, in this case, point v1 and also point v2, automatically each one of them will become the child class of the object class. And in the object class, you mentioned about toString method before. Whatever method that's actually in the object class will be inherited to every class. Equals method is one, and also toString method is another one. So these are the only 2 methods we're going to deal with in this course. Let's say later on, if you get to 2101 or maybe 3101, if your professor actually wants you to implement something called hash table, you will have to override another method called hash code. That's in the object class, but we don't need to worry about it for this course. Okay? But there are other methods too. You can definitely take a look later. All right. So let's see here. Okay, let's do a little bit more. Okay. We got about 5 minutes. Yeah, question.
What does the get class actually depend? Is it the string address? What does it actually depend?
Okay. Okay, a little bit ahead. I'll definitely cover that. But your fellow student was really trying to look at the definition, right? The get class over here. Okay. So short answer. The get class here is going to look at what's the type of objects the reference is pointing to. Or in other way, it's going to return to you some class objects. So class is another class name in Java. So the class is basically going to contain the information about the object itself. I'll get there. Yeah.
But why do we compare between them as not equal, not with the not equals?
Yeah, that's something I can get into. You can think about in Java just a little bit peculiar way to figure out the dynamic type for the objects. We'll get there. Yeah. Mm-hmm. All right, let's now do a little bit more. Okay. Okay, let's talk about the simplest case about default. Okay, let's do a little bit, and then we definitely can continue on Thursday. Okay, let's see what we can do. So let's now review what we know already. So we don't need to do that on Thursday. So first of all, let's start with the default version. We know that this one here is the default version. Yeah, guys, bear with me, just about a few minutes. So this one here is the default version. Inherited to all classes, including the .v1 class. Okay, and then since we observe that since .v1 does not explicitly override or redefine. So when you actually talk about either override or redefine, verbally it doesn't really matter. But just gotta know when I say overriding or override, what that really means. Okay, that's important. Right? Does not explicitly override or redefine equals. So consequence is the default version inherited from objects is used. All right, so that's a very important pattern you want to see. Okay, default version, because it does not explicitly override or redefine. Okay. All right, I think I will pause over here, and then we'll continue with this example here. We're pretty much in sync with the other section. So I would say before Thursday class, so please make sure you can review what we have got up to now about the two different potential versions. We're going to dive deep into how you can implement the equals method appropriately in different phases. And just remember, whatever we cover on Thursday will also be covered in the written test one. So please do start the review. All right, thank you. I'll see you soon.